Now consider an electric field E generated by a positive charge. Here is the positive charge, and you have the electric field generated by this positive charge. So that's the electric field. Since E varies with the distance from the charge, the electric field has different values at different points. If you now move from a point close to the positive charge and away from it, you can see the electric field will decrease. The field lines actually tell you that story. How? A region where the field lines are closer, the strength of the field is greater. As you move away, the field lines are widely separated, the strength of the field decreases. So as you move away from the positive charge, the strength of the electric field decreases. Alright, let's place a test charge Q0 in here. A test charge Q0, I want this Q0 to be there. So the Q0 is actually, this is my Q0. Alright. So a test charge Q0 placed in the electric field will experience a force. What is the force experienced by a charge placed in the electric field? Now remember, the definition, the basic definition of electric field is the force per unit charge. So if E is the force per unit charge, if you place a charge Q0 in that field, that the force experienced by that Q0 will be F equal to E times Q0. So a test charge placed here will experience a force E times Q0. Alright, let me take that away now. Now the force F equal to E times Q0. You can see that arrow is supposed to be here and somehow it got displaced. This is the arrow that I meant to put there. That's the arrow representing the force. That force F equal to E times Q0. Alright. Now to move the test charge in the direction of increasing potential. What is the direction of increasing potential? Towards the positive charge. An external force needs to do work. That means an external opposite force is needed and the work done will be equal to negative E Q0. So if you want to move this test charge in the direction of increasing potential, an external force needs to be applied in the opposite direction, and that force will be therefore negative EQ0, because if the force directed in the direction of the field is E times Q0, that is the force experienced by this charge. If you now want to move this charge in the opposite direction, in the direction of increasing potential, you need to apply this opposite force on it. Now, when the test charge is moved at distance dr, if this is the distance dr, if you move the test charge at distance dr, this force is moving through a distance dr. What is the increase in potential energy? The increase in potential energy is a measure of the work done, and the work done is this force multiplied by this displacement, and the force is negative EQ0. So the work done to move this test charge Q0 through a distance dr will be F times dr. That will be, this is F, negative EQ0 is the F, times dr, and that is a measure of the increase in potential energy. Now therefore, what is the increase in potential energy per unit charge? This is the increase in potential energy of a charge Q0. What is the increase in potential energy per unit charge? That would be du over Q0, and that will be negative EdR. Now this has some significance. du over Q0 is called the increase in potential per unit charge, and that is equal to negative EdR. Now this is a measure of the potential difference between the 2 points. The potential difference between the 2 points, between this point and this point. You see, when you move the object from the initial position to the final position, its increase in potential energy per unit charge is negative EdR, and this is a measure of the potential difference between the 2 points. So what is the definition of potential difference between 2 points in an electric field? Potential difference between 2 points in an electric field is the increase or decrease, change in potential energy per unit charge. And it is a measure of the work done on a unit test charge to move it through a distance dr. So the potential difference between 2 points is a measure of the work done to move a unit test charge from one point to the other. You must understand that definition very well. Potential difference between 2 points in an electric field is a measure of the work done in moving a unit test charge from one point to the other. Now, it is similar to the potential difference between 2 points in the gravitational field. Potential difference is the measure of the work done in moving a unit mass from one point to the other. In the same way, in an electric field, potential energy is a measure of the work done, or potential difference between 2 points is a measure of the work done in moving a unit test charge from one point to the other. So we have du over Q0 equal to negative EdR. What does du over Q0 define? Is the potential energy per unit charge, and this is a measure of the potential difference between 2 points at a distance dr apart. We will use V to represent potential at a point, and delta V the potential difference between 2 points separated by a small distance delta r. Then du by Q0 will be your V, because that will be a measure of the potential. So therefore we have delta V, the potential difference. Delta V is the potential difference. du over Q0 is a measure of the potential difference between 2 points separated by distance dr. If delta V is the potential difference between 2 points separated by a distance dr, then delta V equal to negative E delta R. Or E, electric field, can now be defined in terms of the potential difference. A very important concept again. E, the electric field, is negative of delta V divided by delta R. What does delta V divided by delta R define? It is the rate at which the potential changes with distance. You see that? In other words, we can actually write this using calculus. Alright, That's equal to negative dV over dr. So electric field is negative of the rate of change of potential with respect to distance. That is a very important equation. E equal to negative dV over dr. Well, if you now consider the electric field in the x, y and z direction, we can use this equation. This is the general equation for any direction. Electric field in any direction is negative of dV over dr. That means I can rewrite this. If I use E sub x, electric field in the x direction will be negative of dV by dx. Electric field in the y direction will be negative of dV by dy. Electric field in the z direction will be negative dV by dz, and so on. Now notice that the potential V decreases in the direction of the direction of the electric field. You can see the E and V are oppositely directed. That means the direction of the electric field is the direction of decreasing potential. We talked about it earlier. E equal to negative dV by